Scene script. Have you ever wondered what the future of computing might look like? To understand its potential, we need to take a step back and appreciate the journey that has brought us here. In the beginning, there were vacuum tubes. These were the building blocks of the earliest computers, gigantic machines that occupied entire rooms. They were slow, unreliable, and consumed a lot of power. But they were the first step in a revolution that was to come. Then came the transistor. Smaller, faster, and more reliable than vacuum tubes, transistors transformed the world of computing. They made computers accessible to businesses, and eventually, to individuals in their homes. The transistor was a leap forward, but it was just the beginning. The next great leap was the integrated circuit. Imagine a city with its complex network of roads and buildings. Now, imagine that city shrunk down to the size of a fingernail. That's what an integrated circuit is, a city of transistors. These tiny cities power our smartphones, our laptops, and every other piece of modern technology we take for granted. In the blink of an eye, we've gone from room-sized machines to devices that fit in our pockets. We've seen the rise of the internet, the birth of artificial intelligence, and the dawn of the information age. Computing has transformed every aspect of our lives, from how we work to how we play. And yet we're only scratching the surface. We're standing on the edge of a new frontier, one that promises to redefine what is possible. The future of computing isn't just about faster processors or bigger hard drives. It's about a fundamental shift in how we process information. As we gaze into the horizon, we see a new era dawning, an era where the laws of quantum mechanics govern our computers, where bits give way to qubits, where problems that were once impossible to solve become trivial. We're on the brink of a new era in computing, the age of quantum computing. So, how exactly did we get from classical computing to quantum computing? Well, to understand this shift, we need to take a step back and talk about something called Moore's Law. This is a prediction made in the mid-20th century by Gordon Moore, co-founder of Intel. Moore suggested that the number of transistors on a microchip would double approximately every 2 years, leading to an exponential increase in computing power. For a long time, Moore's Law held true. We saw computers shrink from room-sized behemoths to handheld devices, all while becoming exponentially more powerful. But as we continue to miniaturize these transistors, we're hitting up against the physical limitations of the materials we use. Enter quantum computing, an entirely new paradigm that promises to overcome these limitations. Unlike classical computers that use bits as their smallest unit of data, quantum computers use quantum bits, or qubits. These qubits can exist in multiple states at once, thanks to a property known as superposition. This means that a quantum computer can process a vast number of possibilities all at once, potentially solving complex problems far quicker than any classical computer. However, it's important to note that quantum computing is still in its early stages. There are significant technical challenges to be overcome, but the potential is enormous. Quantum computing, though in its infancy, promises to revolutionize the world of computing. But what exactly is quantum computing, and how does it differ from classical computing? Let's take a deep dive into this fascinating world. At the heart of quantum computing are qubits, or quantum bits. Now, in the realm of classical computing, we're used to dealing with bits that are either ones or zeros. It's a binary world. However, qubits are not as straightforward. They can be in a state of 1 or 0, or they can exist in a superposition where they are both 1 and 0 at the same time. It's like being in two places at once. This brings us to another intriguing concept called superposition. In classical computing, if you want to process 2 bits of information, you would have to do it sequentially. But in the world of quantum computing, thanks to superposition, 2 qubits can process both bits of information at the same time. This increases the computational power exponentially as more qubits are added, and that's something classical computing just can't match. But here's where things really get mind-bending. The concept of entanglement. In the quantum world, 2 qubits can become entangled, meaning the state of one qubit is directly connected to the state of another, no matter the distance between them. Change the state of one, and the other changes instantaneously. It's like magic, but it's not. It's quantum physics at play. Now, compare this to classical computing, where bits are isolated and their states are independent of each other. The contrast is stark. So, where does this leave us? Well, it's clear that quantum computing, with its qubits, superposition, and entanglement, brings a whole new dimension to processing power. It opens up possibilities for solving complex problems that would take classical computers billions of years to crack. The power of quantum computing lies in these unique properties that allow it to process information in ways that classical computers simply cannot. And that, my friends, is just the tip of the quantum iceberg. So, why is quantum computing so important for our future? Well, let's dive into the potential applications of this groundbreaking technology. Quantum computing has the potential to revolutionize many fields, including cryptography, medicine, environmental modeling, and more. It can solve complex problems that are currently beyond our reach, offering solutions that are faster and more efficient than anything we've seen before. Imagine a world where we can crack complex codes in seconds, not years. That's the promise of quantum computing in the field of cryptography. It can decode encrypted data with a speed and efficiency that is simply beyond the capabilities of classical computers. This could lead to a new era of secure communication, protecting our online transactions and personal information from cyber threats. Now let's turn our attention to medicine. Quantum computing can help us understand the human genome on a level we've never achieved before. It can accelerate drug discovery, personalize medical treatments, and even predict the spread of diseases. Imagine the lives we could save and the suffering we could alleviate. Then there's environmental modeling. Climate change is one of the most pressing issues of our time, and quantum computing could be a powerful tool in our fight against it. It can model complex environmental systems, predict weather patterns with unprecedented accuracy, and help us develop effective strategies for conservation. But that's not all. Quantum computing can also optimize complex systems, from traffic flows to supply chains, making our lives more efficient and our economies more robust. It can simulate new materials and processes, accelerating innovation in fields from energy to manufacturing. In short, quantum computing allows us to solve problems that are currently impossible to solve. It gives us the computational power to explore new frontiers, from the smallest particles to the vastness of the universe. And that's just scratching the surface. The potential applications of quantum computing are as vast as the quantum world itself. We are on the cusp of a new era, one that will be defined by our ability to harness the power of quantum mechanics. The importance of quantum computing lies in its potential to solve the unsolvable, opening up a world of possibilities. But how will quantum computing impact you, as an individual, and the society at large? You might be wondering, well, let's delve into that. Quantum computing, with its mind-boggling computational prowess, has the potential to revolutionize various sectors. And this revolution will not be limited to just tech companies or research labs. It will permeate through our society, affecting every individual in one way or another. Firstly, let's talk about job creation. Quantum computing, being a relatively new and rapidly evolving field, could open up a plethora of opportunities. From quantum programmers and quantum data analysts to quantum hardware specialists, the job market could see a surge in demand for these new-age roles. Now let's shift gears and talk about privacy. Quantum computers can break most of today's encryption methods, raising valid concerns about data security. However, on the flip side, they can also help design new encryption techniques that are quantum-proof, thus enhancing our privacy in the long run. The impact of quantum computing extends beyond job creation and privacy. It has the potential to drive advancements in various fields. For example, in healthcare, it could help design new drugs and analyze complex genetic data. In finance, it could optimize portfolios and manage risks in ways not possible today. In climate science, it could model complex climate patterns, helping us understand and mitigate the effects of climate change. So you see, this quantum leap in computing is not just about faster computers or solving complex mathematical problems. It's about creating a better, more efficient, and more secure world. But to fully harness the potential of quantum computing and mitigate its challenges, we need to understand it and prepare for it. We need to foster a culture of learning and innovation, encouraging our young minds to explore this exciting field. We need to have dialogues about the ethical and societal implications of quantum technology. Quantum computing is not just a technological advancement, it's a societal shift that we all need to be a part of. In conclusion, quantum computing is the future of computing. It's a seismic shift from classical computing, promising unprecedented power and speed. By harnessing the strange properties of quantum physics, we're opening up new horizons in diverse fields, from cryptography to climate modeling. Its potential impacts are vast, and it's poised to revolutionize our world. So keep an eye on this space, because the quantum future is closer than you think. If you like this video, please give a thumbs up and subscribe for other futuristic content.